All right, everybody. So by now I've introduced the binomial distribution, okay, with I guess 3 videos so far. I put all this up here. This was from, I guess, the first video I did on it. And we don't need to go through all that again, I don't think. But let's say a binomial experiment, just to sum it up, is some kind of probability experiment, something you do where you don't know what the outcome is going to be each time you do it. And we'll just consider that there are 2 outcomes, success and failure, whatever you want to call those. Flipping a coin, heads could be success, tails could be failure, and so on. There's a certain probability of success on any trial, a certain probability of failure on any trial, and so on. That's okay. So that's not the whole story, but that's enough. Now, one thing we haven't talked about yet is the mean, the variance, and the standard deviation. And they are just calculated by formulas like so many other things in math, okay? So now the mean first is n times p. N is the number of trials in the binomial experiment. Remember, a binomial experiment can't be open-ended. If we say, all right, I'm going to flip a coin, I have to tell you I'm going to flip a coin this many times, all right? It has to be definite. It can't be open-ended. So n is the total number of trials that I'm going to undertake, okay? And p is the probability of success on any trial. So the mean of a binomial experiment, binomial distribution, whatever you want to call it, is n times p. The variance, sigma squared. Oh, those are the symbols. I'm sorry. So the mean, I might call it the mean. It goes by the Greek letter mu, and I know that that looks like the letter U. It's a Greek letter. N times p, though. That's how you calculate it. The variance, there, the symbol is sigma squared, but that's np cubed. So n, the number of trials, times p, the probability of success on any trial, times q, the probability of failure on any trial. np cubed, that's the variance. You get the standard deviation, known by the symbol sigma, as the square root of the variance. Okay? Now, mean, variance, standard deviation, those are things introduced way earlier in the course. The mean tells you where you can expect the data or the measurements to be. It's a measure of central tendency or a measure of like a typical data entry. And the standard deviation tells you how spread out the data is. You know, if you had a bunch of measurements, a bunch of data, a bunch of numbers, they could be all real close together, or they could be way spread out. So the mean tells you where the numbers are, over here, over there, and standard deviation tells you whether they're all bunched up together or way far apart, okay? All right, now that's the very short story on mean and standard deviation. We calculate the variance, I guess, for the most part, to get the standard deviation. Now, let's do an example. Like I guess like the real story is almost always in the example. So here's an example. Suppose that we do a survey, as many things in statistics involve surveys or begin with surveys. A group of US adults were surveyed, and it was found that 78% of them believe that there is life on other planets somewhere, okay, somehow, all right, maybe not intelligent life, but life of some kind. Now, whether or not that's true, I don't know, like, who knows? Like, this is just what people said they believe. Like, people believe all kinds of things, whether or not it's true. The survey doesn't try to figure out what's in fact true, just what people believe, all right? So 78% believe that there's life on other planets. Okay, that's up to them. Now, here's the binomial experiment. Suppose that among that survey pool, all those people that were surveyed, you select 5 people at random, and you go through them one at a time and you say, do you believe there's life on other planets or not? And it's like yes or no, okay? It's success or failure. It's a binomial experiment, okay? And the random variable will count the total number of those 5 people selected at random who believe that there is life on other planets. Okay, so here's how we'll get our numbers together. A success in this binomial experiment will be that you take one of those 5 people and you see if they believe there's life on other planets. Okay, so success is that they do believe there's life on other planets. Probability of success, well, if 78% of people are found to believe that, then P, the probability of success, is 0.78. Q, the probability of failure, or in this context, the probability that they don't believe there's life on other planets, is 1 take away 0.78, which is 0.22. And in the number of trials is 5, because you're going to go through those 5 people. Life on other planets, yes or no? Life on other planets, yes or no? Life on other, you see what I mean? Okay, so the mean, now let's just do some calculations and then we'll talk about the interpretation. The mean is n times p, which in this case is 5 times 0.78, which is 3.9. What's that mean? This is on average about 4 of 5 people will believe there is life on other planets, okay? So that's the interpretation of the mean being 3.9. And I guess like it's not, obviously it's not possible that you take 5 people and 3.9 of them believe that there's life on other planets. You could say 4 of them do though, all right? So that's why I'm going to give you the interpretation is about 4 out of the 5 will believe there's life on other planets on average. Like that's the prediction. Okay. Now, all right, that's how you calculate the mean, and that's the interpretation of the number. Variance is NPQ, which in this case is 5 times 0.78 times 0.22, which, if you use your calculator, is 0.858. Standard deviation is the square root of the variance, which again by calculator, root 0.858 is 0.926. Now, here's how I'm trying to think of the best way to tell you this, but I have it written down. I have to think about it. The interpretation of the standard deviation. I would like you to think back to before when we introduced the standard deviation and we said things like most of the data is going to be within 1 standard deviation of the mean. Okay, so the mean tells you like on average where the data is, you know, where numbers can be anywhere, so where is it going to be clustered around, and the standard deviation tells you how far apart. Like, so most data is going to be within 1 standard deviation of the mean. Okay. All right, so let's do like this. If I say most of the time, we do this experiment, we get these 5 people and we ask them one at a time if they believe there's life on other planets or not. Most of the time we'll find that between 2.9 to 4.8 of the 5 will believe this. Okay, most of the time that's what'll happen. It'll be very rare that we find like only 1 or 2, okay? Because I mean, think 78% of people feel this way. I wouldn't expect that you'd take 5 people at random and only 1 of them would feel that way if 78% of people actually feel that way. But you know, we could say, putting all this together, that you know, most of the time when we do this, between 2.9 and 4.8 of the 5 will believe in that there's life on other planets. How do I get the numbers? Well, this is 1 standard deviation below the mean. The mean is 3.9. Take away 0.926. That's how I get 2.9. And this other number, 4.8, is 1 standard deviation above the mean. 3.9 plus 0.926. Now, we could refine this into whole numbers since in reality the data is going to have to be that way. So maybe we could say between 3 to 5. Most of the time we'll figure out that between 3 to 5 of the 5 will believe that there's life on other planets. Okay, so that's how to calculate the mean, variance, standard deviation of a binomial distribution, as well as a way to understand what those numbers tell you.